In the case of the checked exceptions, which you must deal with, you don't have the luxury of ignoring those. You need to deal with them one of two different ways. You either deal with them directly within your code by actually providing a try-catch block to deal with them, or alternatively, you can take the associated method that where potentially an exception could occur, and you simply declare it to throw an exception, and that will be acceptable as well, although it then leaves the onus on the invoking method to deal with it. The invoking method in turn could simply declare that it throws an IO exception, for example, as well, and leave it for its invoker to worry about, and so on up the line. But eventually, somebody needs to deal with this exception. And in order to at least have the compiler allow your code to pass, you need to minimally state that you can throw an exception. It's better if you can deal with it, but sometimes you can't. Sometimes only the method that invoked you will know how to deal with it. And when that's the case, it's out of the question for you to provide your own try-catch block. All you can do is simply throw the exception back to your caller. So in the middle of the slide, you see an example of how we would declare that we throw an exception. You're used to seeing stuff like public void, method name, but now we've added to the end of that some additional information that says throws IO exception. There's other exceptions that we might throw as well, but in this particular example, it's an IO exception. So in other words, if within your method, or my method as it's called here, if it's possible for a particular exception to occur, such as IO exception, you need to either have a try-catch block to deal with it, or you need to state that it can throw an IO exception as we've done here. In the event that there's many different exceptions that could get thrown within your code, then you would want to state in comma delimited order all of the exceptions that could occur. So that's the next example at the bottom of the slide, where we say public void my method throws, and then we have a list of exceptions: exception 1 comma exception 2 comma. In other words, a comma delimited list of exceptions. On this slide we see an example showing where an exception is dealt with within a certain piece of code, as well as where one is simply left up to the invoker to deal with. So if you look at the right hand side of the slide here, method 2, we don't deal with the exception within this code. We simply state that it throws an exception. Presumably it's called by method number 1 on the left side. You can see that here because method number 1 has a try block, and within that try block it invokes method number 2, and that is where an exception can occur. If it does occur, then the catch block within method 1 is going to catch that exception and deal with it. Notice that on the right hand side where it says throw new exception, this might not necessarily be a statement directly within your method 2. Rather, your method 2 could simply invoke some other method, maybe a method that you've wrote, or maybe a predefined method in Java, and that method might be what actually throws an exception. When that occurs, then the fact that you've declared your method 2 to throw an exception is one appropriate way of dealing with that exception. And then the onus becomes on the caller of method number 2, which is method number 1 in this case on the left hand side, to actually deal with the exception. As you can see, once again, that does happen in method number 1, where we explicitly have a catch block to catch that particular exception and process it ultimately. Bearing in mind that an exception is an object, whenever we want to throw an exception, we have to create such an object first. In this slide, we see examples of doing that. In the top case, it says illegal argument exception, and then we see EX equals new illegal argument exception with the string for the constructor of this object that says wrong argument. Here there is a name for the exception. It's EX. So EX is an object of class illegal argument exception. And then once we've produced EX, we can turn around and throw EX. And that's what we do in the second line of code that you see on the slide here. We create the exception object, and then we throw the exception object. Alternatively, we may wish to not give it a name and throw it anonymously. And that's what's happening in the next example. rather than create an object or instantiate an object of class illegal argument exception, we simply throw directly an anonymous new illegal argument exception with the same string wrong argument being passed to the constructor. So either of those methods are fine. Whether or not you would want to actually give a name to the object would depend on whether you intend on doing something else with it at some other time. Remember that the whole idea behind try-catch blocks and exceptions is that we want to make a distinction between what normally happens and exceptional events. So if we think about our radius, in the normal course of events, if somebody's setting the radius of a circle, they should do so with a positive number because radii should not be negative. Having a negative radius would be an exception to the normal course of events. We could deal with it that way as an exception. We could make up something called an illegal argument exception for the radius parameter of our circle. The way could do that then is we would have our set radius method, but we would continue on by saying it could throw an illegal argument exception, and then within the code for our set radius, we could first of all check to make sure that the argument we were passed, that is the new radius, is actually 0 or higher. In other words, it's not a negative number. We do that in the if statement that you see here. So if new radius is greater than or equal to 0, then it's safe to go ahead and set the radius data member of our object to the value of new radius. And we then go ahead and do so. Else, otherwise, then we can't do it. It's illegal. We can't have a negative radius. So what we will do instead is throw a new illegal argument exception, and the constructor for that will be given the string radius cannot be negative. And then when the catch block somewhere else deals with this, it will get that exception, it'll catch it, and it can decode the message that's in there as a string and optionally produce some output that explains what went wrong and states that the radius cannot be negative. Although we suggested earlier that there could be multiple different catch blocks, this is the first time we've actually seen an example of it on this slide. So at the top we have the usual try block where there's some statements, but in among those statements there are many exceptions that could possibly occur, and if one gets thrown, that will definitely bail us out of the try statement and off to a catch statement. But now we have multiple catch statements to catch whatever particular exception object has been thrown. They are checked in order of occurrence. So if the exception that got thrown was, say, exception 1, then obviously the catch block will catch it and we're done. If it was exception 2, the first catch block is going to ignore it because it doesn't match, and the second catch block will catch it, and so on up to, in this case, n potential different exceptions. This is a rather complex example in some ways because there's so many different things that could happen, and we have to address all of the possibilities. So if you'll bear with me, we'll go through them very carefully one at a time. The issue here is that at the far right hand side of the diagram, we're told that an exception is thrown in method 3. But that's all we're told. We aren't told in this diagram whether that the exception that's thrown is exception 3 or exception 2 or is exception 1. And which exception gets thrown will have an impact on exactly which parts of the code we see here in terms of try and catch blocks do and do not get executed. So we're going to have to take all three possible situations in account one at a time. And for each, we're going to have to show what would happen in that case. So let's start with the situation where method 3, not shown in the diagram anywhere, it's called from method 2, but method 3, let's assume that when it throws an exception, it throws an exception 3. And let's deal with that example first. So we're going to go through the entire example that way. Let's begin then on the far left with the main method. So the main method begins to execute, and there's a try-catch block here. It does the try block, and when it invokes method number 1, control is transferred over to method number 1, and in there we find another try-catch block. So that begins to execute. And within that try block, method number 2 is invoked as the first thing that happens. So we then move over to the block on the far right hand side, method 2, because we've just invoked it. And now it has a try catch block, so the try block will be executed. And the first thing in the try block is an invocation of method 3. So we're off to method 3, which isn't shown on the diagram, but we're told that an exception gets thrown, and we're considering the case where the exception that got thrown was of class exception 3. Now that we know it's exception 3, what will happen? Well, we know we're going to bail out of the rest of the try block, so statement 5 is never going to execute. We move on to our catch block, and we check to see if this is an exception 3. If it is, we'll catch it. Well, it is an exception 3, so we are going to catch it, which means we will process exception 3 in the next line, in fact, the only line inside of the catch block. And now that we've dealt with that exception, we move on to the end of the try-catch block, and we execute statement number 6. We then return to our caller, which is back in method 1, and we execute statement number 3. We've now completed the try block, and from the perspective of method 1, there was no exception because it was completely handled by exception number 2. So therefore, we skip over the catch block, we execute statement 4, and we are done. And now we return to our caller. Our caller is the main method on the far left-hand side. So we return from invoking method 1, and we find ourselves at statement 1 at the tail end of the try block in the main method. We go ahead and execute statement number 1. We then skip the catch block, but we're done the try block, and we move on and do statement number 2, which follows the try catch block. And that's the end of that story. Now we have to do the whole thing over again, this time in the context where the exception that gets thrown is not exception 3, but let's pretend this time around that it's exception 2 instead, and let's see how this is going to be different. So again, we start at the far left with the main method. We execute or invoke method number 1. We find ourselves in the middle block. We do that try block and we invoke method number 2, and now we find ourselves at the far right. We do the try block that's there. We invoke method number 3, which isn't shown, but this time when method number 3 throws an exception, it's not exception 3, it's exception 2. Now how will things be different that it's exception 2? Well, we're still going to bail out of our try block because it's an exception that's been thrown. So we're not going to do statement 5 still. We're going to go to our catch block like we always would for any exception, but we're going to find that we can't catch this exception because it's not exception 3. So we're not going to do our catch block either, and we're going to bail out completely so we never do statement number 6. The exception that was thrown has not been caught yet. So we completely bail out now out of method number 2 and find ourselves back in the middle block in method 1. And now we're going to find that there has been an exception thrown, so we can't move on to statement number 3. Rather, we have to bail out of our try block and move on to our catch block. Our catch block attempts to catch the exception, and it can, because our catch block is designed to catch exception 2, and that is what got thrown, exception 2. So we go ahead and process it. Now all is well with the world. The exception's been dealt with, so we gracefully move on to statement number 4 and execute it. We return to our caller. We're now in the initial try block on the far left in the main method. We execute statement number 1. We then move on to statement number 2, and we're completely done. So one more go around. This time, let's assume that method number 3, again not shown in the diagram, throws an exception 1. And let's see what happens this time. So the whole thing we have to go through yet one more last time. So we begin once again with our main method. It has a try-catch block. We do the try block. We invoke method 1 to start with. We find ourselves in the middle block now, and there's a try-catch block in that code. The first thing in the try block is an invocation of method 2, so we now move on to the far right-hand side to method 2. There's a try-catch block in there, so we do the try block first. The first thing that happens in the try block is an invocation of method 3, so we go off and we do method 3, but method 3 throws an exception, and this time it is an exception 1. So, because an exception has been thrown, we bail out of our try block. We do not finish it, so we don't do statement 5. We move down to our catch block and we see if we can catch the exception, but we can't because our catch block is designed to catch exception 3, and that's not what this is. So we have to bail out of the catch block. We never get to do statement number 6 again, and we're back in our caller where we left at statement, well, we would go on to statement 3, except that an exception is still in play. An exception has been thrown and not caught yet. So we have to bail out of our try block. And again, we're in the middle block at this point. So we move on to our catch block and we try to catch it. We can't because we can only catch exceptions 2, and this is an exception 1. So we have to bail out of our catch block. We're never going to do statement number 4, and we return immediately to our caller, which is on the far left, the main method. We then would execute statement number 1, except we can't because we're in a try block and an exception has been thrown. So we must bail out. And in bailing out, we go to our catch block. Our catch block has been designed to catch exception 1s, and this is an exception 1 this time. So we go ahead and we catch it, we process it in the next line, in the only line that's in the catch block. And now the thrown exception has been dealt with, so we can continue on and we go ahead and do statement number 2 in the main method this time. Wow, so that's the whole different combinations of things that can happen depending on which exception was thrown. Now, incidentally, let's suppose that an exception 9 had been thrown. Then we would go through a very similar story to the last story we had, except what would happen there is when we tried to catch the exception, our catch block in the main method can only catch an exception 1, so it would not be able to process the exception. We would immediately return to our, well, we can't because this is the main method, so that's sort of the end of the road. But if we had another caller that we could return to, we would, and hopefully that one would be able to process exception 9. In any case, that's not what's happened in the diagram. We only have the 3 possible exceptions that we're dealing with. So, as complicated as that was, that just about completes this slide. The only thing I guess I should mention is that you notice on the bottom of this diagram, there's a call stack representing the fact that the main method calls method 1, calls method 2, and as you move off to the far right hand side of the bottom section of the slide, finally method 2 calls method 3. As this process of try catch blocks is done, we refer to this as stack unwinding. In the case where we do have multiple catch blocks like we saw a couple of slides ago, it's important what order we list those blocks in, particularly when superclasses and subclasses are involved. And we're going to discuss in the next slide why exactly that's an issue by way of a particular example. Now, many slides ago, we looked at this sort of inheritance diagram between all the different exception objects, and you may recall that exception is a parent of runtime exception. So bear that in mind while we look at this slide to understand why the order of the catch blocks is not going to work on the left hand side, and in fact the correct order is that shown on the right hand side only. The reason for this is we have this is a relationship between child and parent. So a child object is a parent object as well. Now, since that's the case, consider what would happen in the version on the left-hand side, which is the wrong order, if we were to put the catch blocks in the order that you see them listed here. So we have a try block, and then we have 2 different catch blocks to catch 2 different possible exceptions that might arise. But remember, a runtime exception is an exception. So it's just as good to use a runtime exception in any context where you would require an exception, because you can use a child wherever a parent is required. So exception's a parent, runtime exception is a child. Now, can you imagine what happens then if a runtime exception is thrown in our try block? Well, what will happen is the first catch block will catch it, because a runtime exception is an exception. It has the is a relationship with its parent, which means even though it's not strictly speaking an exception, it was a runtime exception, that makes it an exception. So that means the catch block, the first catch block, is going to not only catch exceptions that are thrown, but it'll also catch runtime exceptions that are thrown, which means the bottom catch block will never ever execute. That's why this is the wrong order. Now, if you flip the order around, as you see in the right-hand diagram, then everything is fine, because now let's take both scenarios. Let's consider a runtime exception and let's consider an exception. So now if a runtime exception is thrown in our try block, the first catch block will catch it, but it will ignore an exception object, because a parent is not a child. A parent can be a child, a particular child. So in other words, an exception could be a runtime exception, but in general it might not be. Whereas going the other way, all runtime exceptions are exceptions. So the is a relationship only works in the one direction. So that means if a runtime exception is thrown, we will do the first catch block, but we will never reach the second block. If, on the other hand, an exception is thrown, we will not catch it with the first block, because an exception is not necessarily a runtime exception. So we'll skip the first catch block, and instead the second catch block will catch the exception object. So that's the right order to make sure that both kinds of exceptions actually get caught and processed appropriately. Earlier, it was mentioned that in the case of checked exceptions, you must deal with them. And what that means is you either have to catch them or you have to declare them, one or the other. So let's suppose we have a method P2 defined in the following way. We declare P2 to throw an IO exception, and then within P2, if a file doesn't exist, then we're going to go ahead and throw a new IO exception with the string file does not exist. So bearing that in mind, let's continue on to the next slide to see what different options we have in terms of dealing with the IO exception, which is a checked exception, which means it's one that we cannot ignore. We need to deal with it. Well, there are two different approaches we could take, and they're shown in diagrams A and B. You must do one of these two possible things if it's a checked exception, and IO exception is a checked exception, which means we need to deal with it in some way. In diagram A, what we have done is explicitly provided a try-catch block to deal with it. So if an IO exception does occur, we will indeed deal with it and process it accordingly. If we don't want to deal with it right here within method P1, we don't have to, but we still have to do something because it's a checked exception. So the alternative is what you see happening in diagram B. We have no try-catch block. An exception could still happen, an IO exception in particular, but what we do to deal with it is simply pass the buck, so to speak. We give it to our caller, and we do that by declaring P1 to throw an IO exception. It doesn't mean it will throw it, but it means it might, it could. It has the possibility of an IO exception happening in there. And that's good enough. We've dealt with it then. Even though we've passed it up to our caller, that's good enough. And now we've dealt with it, so the compiler will be happy and it will allow that to compile. So either of these approaches, where we deal with it directly ourselves in A, or whether we pass it back to our caller to deal with it by declaring that our method throws an IO exception, both those approaches are perfectly fine and will work just fine. Now, just by way of conclusion, it's also noteworthy that sometimes we might not be in a position to provide a try-catch block because we might not know the appropriate way to deal with it, because it may depend on our caller, and that would be a very good reason for simply throwing it back to the caller, because we might get called from a number of different methods, and how we react to an IO exception might depend on who our caller was. So in that case, we would certainly take option B and simply throw it back to our caller where it could be properly dealt with.